Hello, I'm Nimpuinte. I'm a student studying Masters in Data Science and Innovation. In this presentation, I'm be demonstrating how I implemented decision tree algorithm. These are the steps I'll be going through today. So, what is the decision tree? Decision tree is a supervised machine learning algorithm. It can be used to solve classification problems when the target variables are binary, and as well as the regression problems when the target variables are continuous. In this experiment, I'll be using breast cancer diagnosis dataset from scikit-learn. The target variables are 0 and 1, so this is considered the classification problem. So this is how the original dataset looked like with all the variables with the continuous value. So as part of data preparation, I'm trying to discretize the variables because the idea is to limit the infinite number of degree of freedom and using the quantile approach by binning the values into four intervals. So after discretizing, the final data will look like this. So after binning, the discretizing, the value will look like this. So next is to build a decision tree. How to build the decision tree? So there are two main important features: information gain theory and entropy. Information gain tells us how much information we can gain out of one attribute in order to make the decision. So in the whole decision tree building process, we have to find out the information gain of each and every attribute. So here, the attribute with the highest information gain is considered the root node of the tree. So here, but how to calculate information gain? It is where how to calculate information gain of the attribute. It is where entropy comes into play. Entropy comes into play. So here, entropy means randomness. Randomness of the target variable in that attribute is subtracted from the entropy of the target in the entire dataset. So this is the information gain. So how to compute the entropy? So for one attribute, it can have a number of possible values. In our case, one attribute has 4 values, Q1 to Q4. So this is the index of rows having particular value in the attribute. For example, Q1. So this is the subset of the target array. So okay, we are here to calculate the entropy. So probability of 1 in that array of target, and probability of zeros are calculated. So the entire entropy is the negative of sum of product of probability and log of probability. So this is how entropy is calculated. So entropy of every values is added up in order to make the entropy of the entire attribute. So here, so once the root node of the tree is decided, the other sub-nodes, sub-trees of the node will be built in the same manner, in the same way, in iterative manner. So let me build this. So here I'm going to build a decision tree using the training set. So 80% of the whole original data sample is used for training that model, and 20% is used for testing purpose to evaluate the performance of the tree. So let me build the tree here, and then the tree is being built. So after tree is being built, we need to evaluate the performance. How to measure the performance is using the performance. So firstly, we need to get the prediction first. So the predict function in the tree allows the test sample to traverse the tree through the nodes we already built. So all the predicted values are stored and compared against the actual target values. So confusion metric idea is applied here to calculate the accuracy and error. So in our case, both false positive and false negatives are considered critical in this scenario. So error rate is related and the accuracy is here. So what is the performance? The accuracy is 92% and the error rate is 7%. That's all.